Oh, hi there. Welcome back to a terrific Math Tuesday. And the final few questions of the linear relations review questions for EQAO. We start with some hot new wheels. Sibel and Peter each buy a car. Different cars or the same car? They buy a car together. Oh, this is the value of Sibel's car over time. Okay, so they each buy a car. So this is Sibel's car over time. Of course, the car loses value as you own it. And they don't usually do this linearly. They usually do this in an exponential way. I'm just going to get a little technical here and say that we would expect it to do something more like this. There's a bottom limit that it will approach and never go below. You can always sell a car for scrap. And now you can never if this continued, there'd be a point where you'd be like begging people, please take away my car. It has a negative value. That doesn't make sense. Cars won't have a negative value at any time. They will always have a positive value. That value might be close to zero, but it won't be below zero. And the line will go below zero. Okay. So anyway, this is probably exponential. It's not linear, and they're giving you a line because that's what you know how to deal with. Okay, so this question is not quite so applicable to the real world as you might think. Still useful to think about. Okay, let's see. So Peter's car cost less than Sybil's, and the value of both cars changes at the same rate. Okay, determine a possible equation to represent the relationship between the values of Peter car V in dollars and time t in years. Okay, so here's what we want. We want his car to start at a lower value. I am going to pick $16,000 because that gives me convenient grid points to go through. And the value changes at the same rate. So watch this. If this I go over 2 years, I go down $4,000. So this one, if I go over 2 years, I should go down $4,000. Oh, wouldn't you know? This is going to create a line which is parallel to the other line. Why is it parallel? Because it has the same rate of change. The two cars will never have the same value. Peter bought a cheaper car than Sybil's, and it will always be worth less money. Okay, so there. So now let's put an equation together for that. So let's do, we know the B value is equal to $16,000 because I chose that. I chose to start this right there. And so that's $16,000, right? And then what's the M value? Well, that's equal to rise over run. And let's find the rise over run. I already have the two things drawn there, so let's use that. Okay. If I go over 2 years, I lose how much money? $4,000. All right. So let's put that in. Notice I got the signs right. I went positive 2 years. 2 years in the future, the car will be worth 4,000 less. Must get the signs right. Minus 4,000 over 2 equals minus 2,000. Okay, there's my M value. So now let's put those in here. And so we would say that the V, so we have this number and that number that are important. V equals minus 2,000 times t years, okay, plus the initial value of the car, 16,000. And then justify your equation. Peter's car, I'm just going to do it orally. I don't need to write it out for you, so you're going to listen here. Peter's car starts $4,000 less expensive than Sybil's, and it depreciates at the same rate of $2,000 per year. Therefore, the value of both cars changes at the same rate, but Peter's car costs less. Okay, let's keep going. Which is which? Relationship between the total cost to use a gym for a month C and the number of visits N is a partial variation. The total cost for 10 visits during 1 month is $50. Okay, draw a graph that could represent this relationship. Label each axis with an appropriate scale. Okay, here we need to know what the heck is partial variation. All right, so this is something that I've only talked about ever briefly, but here's basically direct variation is some linear relation that goes through the point 0, 0. So if I told you I use 3 times as much sugar as I use flour. So if I use 1 part flour, I use 3 parts sugar. If I use 10 parts flour, I will use 30 parts sugar. If I use 100 parts flour, I will use 300 parts sugar. But if I use 0 parts flour, I will use 0 parts sugar. Okay, that would be a direct variation. Another example of direct variation is dollars per hour. If you work 0 hours, probably you made $0. So if it includes that 0.00, it's direct variation. And their equations, they don't have a b. Like if I say this is y is equal to $15 per hour multiplied by the number of hours, that's the whole equation. But that's not true for everyone. Maybe you want to, or for every situation even. Let's say that you earn, or let's say you have to pay $20 to get to work each day. And you want to know, well, is it worth it going into work or not? And so there you would have y, your total income, is equal to $15 per hour multiplied by the number of hours minus the costs to go to work. This is an example of partial variation. All right. So why is that an example of partial variation? Because it starts down here and then goes up. Okay, it does not go through the 0.00. This is called partial variation. All right. Anytime you do not have the 0.00 on the line or in your data set, it's a partial variation. If it is a variation at all, if there's a any kind of linear relation. Okay, so just 2 families of linear relations. Direct variations go through the origin, they go through the 0.00. Partial variations do not go through the 0.00, but they are still linear. Okay, so draw a graph that could represent this relationship. Label each axis with an appropriate scale. Okay, so let's say people might spend let's say $100 a month to go to the gym. I know it can be higher than that, but I just want that to be 100. And then n is number of visits. We had what in ours? 10 visits. So let's just count 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's just label that the point 20 there. Okay. And then this would be, maybe I need to be a little more careful. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, let's call that 50. We'll go by fives. 50, 55, 56. Oh, sorry, 55. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Let's label this the $100. Okay, not that. All right. And so now this is the point 20 visits, $100 would be up there if that's the case. But it's not actually. 10 visits during the month is $50. So let's put the point 10, 50. That has to be on our line. So 10 visits, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the point 10. And then 50. Oh, we had it. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There's 50. Okay. And so bring those together. That's the point 50, 10. And we're happy with that. And then let's say it's a partial variation. So we can't go through the origin. It has to be through, like, let's say 5, 10, 15, 20, 25. Let's go from there. Go through that point about like something like that. Okay, that should go through the 0.75 there. Okay, there. Determine the equation for your graph. So this is 25 here, and so it will be c is equal to plus 25. The b value is 25, and then what's the rise and the run? Well, it rose by $25 after 10 visits, so that would be 2.5 times the number of visits plus $25. There, done. Explain how your equation represents a partial variation. There's a few reasons I know it represents a partial variation. One, I see from the graph that it is linear, but doesn't pass through 0, 0. So it's not direct variation. It's partial variation because it has to be linear and it can't pass through 0, 0. And then it's partial variation. Number 2, from the equation, this is the answer they're looking for. I see it is it meaning the equation. Okay, I see it is of the form y equals mx plus b, and b does not equal 0. If b equals 0, it's direct variation. If b is 0, it's part of it. If b equals 0, it's direct variation. You wouldn't see a b. You would just have 2.5n. It would cost you $2.50 for every gym visit. Okay, the bouncing ball. All right, let's do another question here. Follow it. The scatter plot shows a relationship between the rebound height of the ball and the height from which the ball is dropped. I'm making a face because I don't believe this would really be linear. Okay, but who cares what I think? And it might be linear over small sections of the data. Okay, draw a line of best fit for the data on the grid above, determine an equation of the line of best fit, and show your work. Okay, I wish I could do straight lines in this program. It certainly feels like it should go through 0, 0, doesn't it? If it's linear, which I don't believe it would be, but anyway, their data set's pretty linear. If you drop the ball from 0, so I drop the ball from here, is it going to bounce? No, it's not going to go like that. That'd be a weird ball. Okay. So if you drop it from 0, 0, it's going to bounce 0 high. So it will be direct variation. The height at which it bounces varies directly with how high you drop it. Then we draw a line through the data as best we can, trying to get some of those points above and below the line. And then what I need to do is I need to go through and find a good point here that I can use. I'm going to say... I actually didn't get a good integer point, which is fine. I can work with this point here as a pretty good one to work with, and I would say that that's the 0.3, and then that's a little bigger than 1.5, but this is 1.75. It's like 1.5. It's like 1.51, 1.52. I'm going to say 1.52. Okay, 3, 1.52. And I probably don't need to be better than 1.5. I could probably use this point down here, but who cares? I'm going to try and improve it a little bit with 1.52. Okay, so now all I need is a line of best fit. And oh, look, I have another point. It's 0, 0. That's a really good point because it tells me b equals 0. So I know that this will be an equation of the form y equals m times x. And then to find m, I just need the rise over run of this, or I just need to take this point and sub it in to find m. Okay, and you'll find that actually doing the math one way or the other way gives you the same result. So I'm going to put in for y, 1.52 is equal to 3 multiplied by x. Oh, sorry, oops. Jeez, Mr. Jennings. Jeez. M multiplied by 3. X is 3, and y is 1.52. Okay, now watch what happens when I divide both sides by 3. Look at that. Here's the rise. Here's the run. See how it worked out exactly the same? This is a run of 3 and a rise of 1.52. So it shows you it doesn't matter what order you do your math or how you understand it. So long as your understanding is correct and you're following the rules of algebra, you're going to get the right answer. All right, so what is 1.52 divided by 3? Well, it's very close to a half. It's slightly bigger than a half. Let's see, what exactly is it? 1.52 divided by 3 equals 0.50, and then that weird 2/3 thing that happens down there. Okay, so I'm going to say 0.51. I'm going to round to 0.51. M is approximately equal to 0.51. So determine an equation for your line of best fit. So my line of best fit is y is equal to 0.51 multiplied by x. Done. And I showed my work. Equation of the line of best fit. I'll write it there so that the grader knows that you know it's y equals 0.51 times x. Picture perfect. The cost of producing a family photo album is 50 cents per photo, plus a fixed cost for the album. Circle the table below that represents this scenario. Well, this looks pretty good, doesn't it? Because it's growing by the correct amount. If it's 50 cents per photo, then this is growing by the correct amount each time. Problem is, the fixed cost for the album here is $0, and I don't think that's what they meant by a fixed cost. Okay, let's check this one. This one we went no. This one is going up by 50 cents for every 5 photos, not 50 cents per photo. Okay, so it must be this one that's correct. This one, yeah, this one's absolutely correct here. Notice that this went up by 250. This went up by 250. And this went up by 250. So it's linear. And why is it linear? Well, it's growing by the same number over here each time, 5. And each time it grows by 5, it grows by 250 over there. Well, that makes sense because 50 cents per photo. 50 cents times 5 is $2.50. So that gives us our growth there. Justify your choice and include an explanation of why I didn't choose the other options. Circle the table below that represents this scenario. Okay, so I'll circle this table. Okay. Now, why did I justify my choice? Use text. I chose option 3 because it grows by 50 cents per photo and it has a fixed non-zero cost for the album of $1.35. Okay. How do I know it costs $35 for the album? Because if I went back one here, that would bring me to 0 photos and $35. Okay. So there. I don't think they would want anything more than that for full mark. So let's keep going. Getting paid. Who don't like that, getting paid? Well, Hannah likes that. Her total pay includes a base salary and a percentage of her sales. The following table shows her total pay for 3 different sales levels. If she sells $15,000, she will take home $1,700. If she sells $17,500, she takes home $1,825 and $28,000. Good work, Hannah. She takes home $23,050. And considering that that's her pay for a week, that's not bad. I don't know how long it takes her to make that much money. These questions are pretty old. They might have thought of these as like a month. Okay, so let's just use our her sale. If her sales are really high, what will her income be? Okay, so there's a variety of ways to do this. You could use graph paper, and then you would plot the different points, extend your line, and then say if her sales are this much, what will her take-home pay be? That much. Okay, but I don't recommend that. I would just find an equation. The most awkward would be trying to walk this up with using the table. This gives you a 2,500 increment that you could add on, but it's not going to line up nicely for 28 and 47 here. It's just kind of awkward. Let's see. Is there any tricks that we could use? We want to add $19,000 in sales. I don't see an easy way to make 19,000 in sales here. So find an equation. Equation is going to be the clearest road to a solution, the simplest road to a solution in my mind. So let's do rise and run. We know that this is going to be like her total pay is equal to some amount of money multiplied by her sales plus her base salary. Oh, notice that base salary ended up being B. Okay, that's kind of cool. All right. So this is a y equals mx plus b, and I still have m and b as m and b, but instead of y and x, I have p and s. Okay, so now let's find m. M is equal to the rise over the run, and so let's write that out, rise over run. And here I'm going to actually do some calculations. I'm going to work with these 2 points. I can work with any 2 points if this is indeed linear. Okay, so the rise comes from the change in Y values, change in her pay. So that would be 1825 minus 1700 divided by 1750 minus 15. 17,500 minus 15,000. Okay, notice that these two are over each other in the formula here, and these two are over each other in the formula there. You have to get them lined up in the right way in order for this to work. All right, so that would be an increase of $125 divided by an increase in sales of $2,500. So it looks like she has a commission of about 5%. Let's just check that and make sure that that's indeed 5%. 125 divided by 2500 equals 5%. Okay, there you go. Just trust your mental math if your mental math is really well developed. So that's the M. Okay? Meaning, if she sells $1 worth of stuff, she gets a nickel. And you might think, oh, that's not very fair. No, that can be really good. Okay, imagine that you sell $1 million home, then you get a 5% commission on that, which would be $50,000. And 5% is real estate commission, but that gets split up between the buyer and the seller. So they usually get 2.5% each. And that's kind of standard. You can find people to do it for less, but they might be charging you money for their services. So you want to weigh your options carefully. Okay, so anyway, now we found M. Now we can find P. Okay, so what we do now is we take this value and we put it in for M here. So her total pay is equal to 0.05 multiplied by her sales plus some value B. And I'm just going to make that a more obvious S there. S. Okay, 0.05 multiplied by S. Okay, now we need to find B. And we can do that with any one of these points. And this one is going to be the nicest one to work with. It's got a lot of zeros in it. So let's put that in. $1,700 is her pay if you take 0.05, multiply it by her sales, which is 15,000 in this case, and then add her base salary. So in this case, this multiplied by a nickel would be, is it 300? Is it 300? Let me see. I don't know. 15, I don't think it's 300. I think I did that the wrong way. Times 0.05 equals 750. Yeah. So there her commission was 750. So her total income is equal to her commissions plus her base salary. And now we find her base salary. You can subtract 750 from each side. To get 950 is her base salary. Okay. So now we have everything we need to solve this question. We know that her total pay is equal to her commission rate multiplied by her sales plus her base salary. And then we were asked to find, what about if her sales were $47,000? Good job for you selling $47,000 worth of merchandise. 0.05 multiplied by 47,000. I had some $47,000 sales as a personal trainer. Not single sales, but months. I think that was some of my better months. Okay, and then plus 950. Okay, cool. So now let's figure that out. 47,000 times 0.05 equals 2,350. Right, yeah, you divide it by 2. And then, yeah, okay, cool. Yeah. All right, so her total pay would be equal to, this plus 950. All right. Notice I did the Bedmas right. I did the multiplication first, and then I added it to get 3300. Put a dollar sign on that. Therefore, her pay would be $3,300 if her sales were 47,000. Great, counting pennies. Count pennies. All right, number of pennies. 4, total mass 60. Identical pennies are placed in a container and the total mass is recorded. The table below gives information about the total mass, different number of pennies, in the container. Huh. Okay. All right, using the data to determine the number of pennies in the container with the total mass is 183. Justify your answer, and you may use a grid if you wish. All right, so you can use a grid. Again, I just use an equation. I'm going to do this faster than I did the previous question, but you'll see why. So I know it's going to be y equals m times x plus b, okay? And b, I suspect, is going to be 0. B equals 0, question mark? Because if there's 0 pennies, you would think... but the total mass, I think it includes the container and the number of pennies. Okay, so I think B might be the value, the weight of the container, and then M is the weight of 1 penny, and X is the number of pennies. Okay, so and let's determine it. First, we're going to find M from these 2 points. So this increases by 2, and this increases by 5. So you have M is equal to 5 over 2. Okay, the increase in the total mass, which is the increase in y, over the increase in number of pennies was 2, so 5 over 2. So y is equal to 2.5. I'm trying to embrace the decimal. X plus some value b. We don't know b yet, so let's find b using this point, 460. Okay, so when the weight is 60, we had 4 pennies, 2.5 multiplied by 4 plus some value b, which is the value of the container. B is not 0. I'm revising that assumption. Okay, and so 2.5 times 4 is 10. Okay, so b is 50. Okay, so I said I would go faster, so 50 equals b. Okay, so there I found b, and now I know y is equal to 2.5 multiplied by x plus 50. Okay, 50 is the weight of the container, 2.5 grams is the weight of each penny, and that gives you an equation. The number of pennies in the container when the total mass is 185. Okay, so I need a little bit more space, so I'm going to come down here. What I do is I say y, just copy my equation, is equal to 2.5 grams per penny plus the weight of the container. And then I know that the total mass is 185, so put that in on the total mass side, is equal to 2.5 times the number of pennies plus 50. Why did I do the substitution there and not there? I was told the total mass is 185. So I want to know, like, if I increase my table down to there, how much will I have increased my pennies? Okay. One thing I could do is I could say an increase of 5 gives me an increase of 2 pennies. So that way, I would count the number of increases by 5 I need to get down there. And that would be, that increases by 110. So that's 22 more increases by 5. So that would be 44 more pennies from there. So I predict my answer is going to be 54. Okay, just working with the table, that's what I'm going to get. But here, if I'm working with an equation, I just need to solve this equation for x. I need to find the x value that makes this true. Okay, so first I'm going to subtract 50 from both sides to give me 135 equals 2.5 times x. And then I divide both sides by 2.5. Because I'm multiplying there, so the multiplication helps those cancel. So then x is equal to the result of 135 divided by 2.5, which is 54. Don't believe me? Check a calculator. I just use my calculator. It's 54. Okay, so there you go. Okay, so and then we want a sentence. Justify your answer. Use data to determine the pennies. Justify your answer. Therefore, there will be 54 pennies when the total mass is 185 grams. All right, let's keep going. Go faster, Mr. Jennings. Population plans. Alvin is researching the population of Canada. He finds the data for the year 2001 and predictions for every 5 years after that, as shown below. Okay. Population of millions, number of years since 2000. Okay, so one nice thing about his data table here is this is always increasing by 5. So it sets us up nicely to spot linear relations. Populations don't grow linearly, but like over a short period of time, it might look linear, so sure, whatever. Okay, so here, this grew by 1.1 plus 1.1. This grew by 1.3. This grew by 1.0. This grew by 1.0. And this grew by 0.8. Okay, cool. Okay, so what are we asked to do? He finds data for the year 2001 and predictions for every 5 years after that, shown below. Okay. Determine an algebraic model for Alvin's data and use it to make a reasonable prediction for the population of Canada in 2036. Okay, so we would want to plot this on the graph, all of it. So here's the 1 year, and so there we would put 31.1. You're going to need to find the lines of best fit. You're going to need to plot, you're going to need to draw your graph, and then you're going to need to find the equation of the line you draw. 32.2. Okay, and that's in the year 6. 32.2. So thereabouts. I drew it slightly high, but who's counting? 33.4 in the year 11. There's 33.5, so it's a little lower than that. 33.4. Okay. And then 34.4 in the year 16. Uh, 35.4 in the year 21. So that would be 2021. Okay, because it's since 2000. And then the last data point, 36.2 in the year 26. 36.2. Now, had they given you a graph that kept going all the way to 36, which would be 36 years after 2000, you could have just used your graph to make a prediction. But they didn't do that because they want you to draw a line of best fit through what looks like very linear data, okay? And then find the B value there, which would be very, very close to 31. I'm going to say 30.9. So I'm going to say B is equal to 30.9 to be like fussily close to what I'm predicting there. And then I want to use rise over run, and I'm actually just going to use this 1.1, 1.0, 1.3, 0.8. Okay, so that 0.3 kind of balances that 0.8, but it's a little higher than 1. If I took an average of those two, it'd be like 1.05. And then there's this 1.1, and then these 1.0s. So what I have is I can use that to say, like, what's my rise, what's my run? What's this rise here? And it's averaging out to about like 1.05 or so. This is, again, being fussily accurate. I think 1 is fine. But it's over how much time? 5 years. Okay, so the rise over the run, I'm saying M is equal to 1.05, and I believe that if you use 1, you would get the full marks here, over 5. I don't think you need to be so fussily accurate as me. All right, so that's my M. Now I have an equation. Y is equal to, or I should use like letters that make sense in the context. Okay, so P, and so we were asked to determine an algebraic model, and that's exactly what we're doing. Population is equal to 1.05 over 5 multiplied by T years since 2000 plus 30.9 million. Okay, this is in millions. All right, and then we just input for T, just let's copy that out here. P equals 1.05 divided by 5 multiplied by T plus 30.9. This is a spot I should really get a decimal approximation because I'm mixing decimals and fractions, and it's ugly. Or I can multiply by 100 and drive people crazy. Now, what do we want to do here? We want to evaluate for t is equal to 36. T equals 36. So let's evaluate that. Population is equal to, I'll just do it on a calculator, 1.05 divided by 5 equals, so that's 0.21. I'm going to write that in here, 0.21 times 36 plus 30.9. All right, let's see. Times 36 equals. So the population will have grown by 7.56 million over 36 years. Okay. And I'm going to add that to 30.9 equals. So we get 38.46. So population will be 38.46. Therefore, we would predict that the population of Canada will be 38.46 million. Always check your answer and make sure it makes sense. People. And that kind of makes sense. It's low. I think it's going to be higher than that. It might already be higher than that. Be 30 million people by 2036. And the reason it's low is because populations don't grow like lines. They grow like exponential curves, the same way compound interest grows money. So it's going to be higher than that because that curve is going to pull it above the line that this is predicting. And yeah, let's keep going rather than check that. Someone can check it for me and send it to me. Ezra works part-time in a clothing store. He earns $80 per week plus 6% of the value of his weekly sales. Okay, so $80 base plus commissions. He's not making good money, but whatever. It's fine. Oh, it's part-time, so maybe he works like 8 hours or something. This could be okay-ish. All right, so he earns this much money. What's the total values of his sales this week? Oh, okay. So let's find that out. This is what he earned. So here, let's make an equation. His total pay is equal to 0.06. That's 6% as a decimal, multiplied by S for sales, plus his base salary of $80. Okay. This week, he earned this much. So let's put that in for his total pay and solve for sales. That's all we need to do here. So his amount of money from sales would be $119 minus his base pay, and that will give you the total amount of money he earned from sales. That happens to be $39, and that will be equal to sales if you divide that by his commission. Okay, so there, no one gonna do that in their heads. 39 divided, well, you can actually, but I'm not going to. It's 650. So 650 is equal to sales. Okay, therefore his sales were $650 if his income was $119 for the week. Keep going. Total value of his sales is $650. Notice I put the dollar sign first. Okay, sales goals. Oh, we got a lot of these commissions questions because they do tend to create these lines. Okay, so Alexis works part-time at a clothing store. She's paid an hourly rate of $10.25 an hour and also earns a commission of $3.5% of her total weekly sales. Alexis works at the store 12 hours a week. Okay. And if Alexa's goal is to earn $150 every week, what do her total weekly sales need to be? Okay. So her total pay will be equal to her commission rate, which is 0.035 That's 3.5% as a decimal. Move the decimal place once, twice. So it creates a 0 there, a 0 there. So it's 0.035. That's what that is there. Multiplied by her S sales plus her B base rate. But what's her base rate? Well, it's this per hour, but she works 12 hours. So that's going to be 1025 times 12, which is $123. I'll check it in a calculator so you know I'm right. So B is equal to $123. That's how much she's making hourly because she works 12 hours and this is her hourly rate. Okay, so her total pay is equal to 0.035 times sales plus 125. But we know her goal is to make $150 each week. Oops, did I write 5? I meant 3. So her goal is 150. So she needs some amount of sales plus her base rate. Well, 150 minus 123 would give us, what's that, 27. So she needs to make $27 in commission a week, which honestly is a really low goal. She should be, she could try a little harder here. 27 is equal to 0.035 multiplied by sales. So now we divide both sides by 0.035. And then we multiply 27 divided by 0.035 equals about 771.43. Okay. 771.43. Notice I kept 2 decimal places. That's because it's money. And I would say, therefore, she should sell $771.43 of merchandise each week to meet her income goal. To color or not to color? Okay, the graph below shows the cost to print a document at the graphics shop. All right, and so notice that as soon as you walk in the door and you say, I want to print stuff, they're like, $5 gets you started at our store. Okay, $5 and we'll print 0 pages. And you might say, well, that's not a good deal. And it's like, don't worry, it's a better deal the more pages you print. Because this is a partial variation, does not go through the point 0, 0 down here. Okay. For a 500-page document, how much more will it cost to print in color than with black ink only? Show your work. All right. So if we extended this all the way to 500, you can imagine this line B is going to be way below this line A, right? Because I've gone over a big squiggly there. So there's going to be a big gap. How big is that gap is what this question is asking. We can't use a graph to solve this question because it's too gross. It's way too big a number. But algebra is going to be fine. All right. So one thing I notice is that it goes through integer points here at 4. So that's going to be nice to give me my rise and my run. Okay. The black and white rose $1 for every 4 pages. The color rose $2 for every 4 pages. Okay. So here's black and white work. M is equal to $1 increase per 4 pages. For color, the M is equal to $2 increase over 4, which is, so color costs 50 cents per page. Black and white costs 25 cents per page. Okay, so what's the difference? A difference is 25 cents per page. And for 500 pages, 500 times 25 cents is going to give you $125. Don't believe me? Here we go. Here is the cost for the black and white printing, not including this $5 B, this $5 starter fee. Okay, this is what it costs to print 500 pages at 50 cents per page. And then I would add $5 to that. Okay, so that's the cost to print color. Here's the cost to print black and white. It's 25 cents per page times 500. which is 125. What's 250 minus 125? That's 125 also. Okay, so there. Therefore, I'm not going to show my work. It says show your work. You should show your work, but hey, we all have things to do. And I think if you've not understood the explanation so far, then you can evaluate that. The total cost to do the black and white printing would be 130. Would be the total cost. The total cost for color would be 255. The difference between 130 and 255. So if I take 255 and subtract 130, $125. Therefore, it costs $125 more for color printing. Of 500 sheets. Okay, let's keep going. Last one. What's the charge? Okay, this is the difference between cost and repair time. This is a relationship between cost and repair time. And so we've been asked to find the initial value. So frequently, if you bring an appliance store, well, probably they're doing home visits because you don't bring your dishwasher to the appliance store, or you don't say, "Oh, my fridge is not working," and then pay movers to move your fridge to the store and then move it back again. That would be very inefficient. What you will do instead is the technician will come to your house and fix the appliance where it sits. So to get that person in the door, you have to pay money. For 0 hours, got to pay money for that, okay? Because they have to show up. Now, that's the initial value, or the flat fee, or the starting fee, or whatever you want to call it. All right. So if we this is a real easy way to do this with a table. It's I notice that this is increasing by 3 here, and if I decrease by 3, then I get to 0, right? 3 minus 3 is 0. So I notice here that this increased by $180. No way. No way the initial fee is $20. So if I decrease that by $180, going this direction, I'll get to $20. Okay? Now I can also do this algebraically. And I do it just by finding the equation of the line and finding the b value. I could do it graphically as well, but that would be my least favorite way. Okay. Notice that this point is not that useful because here we increased by 2 hours and it went up by, should be 120. And indeed it is 120. Okay, that increased by 120. So it is linear because this increased by 2. So it's the same slope all the way through. So what I would do is first calculate the slope. The slope is equal to 180, which was the increase in that, divided by 3, which gives me an increase of $60. So that's saying it's $60 per hour. And then I put that into the formula. Y is equal to 60 multiplied by the number of hours plus the initial value B. And then I sub one of my points. It costs $205 to hire someone for 3 hours of work. I can choose any point. Any one of these points will all give me the same answer. Okay, plus this B value. So $205 is equal to 180 plus B, and then you subtract 180 from each side. I said 20. I made a silly error. It's 25. And then it gives me $25 equals B. So it's $25 to start. And that's way lower than you'll find it is nowadays. It's like closer to $100 to get started on appliance work. And then $60 an hour. Sounds about right. Might be higher. I don't know. We'd have to look into it. But anyway, that's how you would do this type of question. So if you got questions, I got answers. You just got to send me an email and I'll help you out. Bye for now, everyone. I hope your math practice is fruitful. The magic word for today, if you email me this word, you get a bonus high five. The magic word is acoustic guitar. I got nothing. I look over there, I saw an acoustic guitar. That's the most creative thing I can come up with right now. I've recently learned that the creative mind and the logical mind, like if the logical mind gets going, the creative mind doesn't want to come out and play. And the opposite is also true. So maybe if you have like art and math in the morning, that's not so great because your mind has to do this big flip. And then in the afternoon, you've got like drama and science. Maybe it would be better to have art and drama in the morning, and then have lunch and have your mind rest, and then you can turn on your logical mind and math and science in the afternoon. Maybe that's better. In any case, I'm not feeling particularly creative, so I had to look over there, find the most interesting thing in my environment, which was an acoustic guitar. So email me the word acoustic guitar, and I'll send you a high five. Bye for now, everyone. Have a great day.